Okay, so welcome back to another video. So here we have an algebra problem that can be solved not quickly, but just quick to some extent. Is we want to find triples x, y, and z such that x plus y divided by x, y, z is equal to negative 1 over 4, x plus z divided by x, y, z is equal to 1 over 24, and y plus z divided by x, y, z is equal to negative 1 over 24. So with common strategies like this, we're dealing with algebra problems that we actually want to do some tricks such that we're actually combining some sort of equations with our given, then in a sense that we're actually trying to get the variables all by itself. But sometimes that's not exactly the easiest, trick to do, since you're going to have some sort of maybe linear combination of those other variables that we're working with. But the matter is we're trying to solve for the value on its own, of course, meaning that we want to solve for one variable on its own to get the exact value we want. So realistically, it doesn't exactly matter how you do this. I mean, there isn't exactly a hard or, the hard way rather. But of course, what matters is you want to find something that's easier to work around with such that you actually get the variable on its own. Hence, you actually can solve for the value from there, which of course, that's the strategy we're going to take. So with that out of the way, let's actually solve this quick and jump ahead. So let me actually first label these equations. So let me just call this equation number 1. We're going to call this equation number 2, and we're going to call this equation number 3. Okay, so let's actually take equation number 2 and equation number 3 and let's actually add those together. And so what we have is we have x plus y and then we have 2z, so plus 2z, all this being divided by x, y, z. And of course, this is actually simply just going to equal 0. And simply enough, we can actually just multiply the denominator x, y, z to both sides. And so that'll just cancel the denominator out on its own, yielding us with just x plus y plus 2z simply just equals, of course, 0. Then what we can do is let's actually solve for the combination of x plus y. There's a reason why I have an x plus y, so that's actually one step ahead that we actually want to get ourselves into and familiarize such that we can actually, take things a little further ahead to solve for the variable on its own. So yielding us with x plus y is equal to negative 2z. Okay, so with that in mind, of course, this is not the final answer, but what I like to do is I'll actually just box this equation just so it's actually of some sort of importance. So with this in mind, let's actually now continue forward and go to the next step, which is dealing with going to x plus y divided by x, y, z equals negative 1 over 4, aka I could have just called this equation number 1. So with that in mind, let me actually switch to another marker for this. So that means from equation 1, that means x plus y divided by x, y, z. Simply, we just put in that substitution over here. So that means negative 2z divided by x, y, z is simply just equal to negative 1 divided by 4. And that being the case that we have z's that cancel each other out. So that means we're just left with negative 2 divided by xy is equal to just negative 1 over 4. Then simply enough that we can actually solve for itself, we're actually going to get x times y by itself. And if you solve all this out, so of course, let me just multiply negative 4 to both sides just to get rid of that denominator over here. That'll become a positive. So that means I have a positive 8 divided by xy equals 1. Just multiply the xy to both sides. That gets rid of the denominator and we're just left with x times y is simply just equal to 8. So with that, of course, let me actually box this equation of importance. So there's more coming up and there's a reason why that this is actually going to be useful for the next step that's going to happen. Let's actually go to x plus z divided by x, y, z. So there's a reason why I have an x times y by itself that we can actually just substitute that back in. So x plus z, then substitute the xy with the number 8. So 8 divided by z, so simply just equal to 1 divided by 24. Then what I can do from here is actually just split the linearity of, the rational, the fraction over here. So I'll have us with 8 or x divided by 8z. So z divided by 8z, that's just 1 over 8. So let me actually take further one step ahead and just subtract that from both sides. So that's 1 divided by 24, then subtract 1 divided by 8. Then, of course, 1 over 24 minus 1 over 8 is simply just going to equal to just negative 1 divided by 12. Then that just yields us with the left-hand side and the right-hand side. Then what we can do is now let's actually solve for x. And simply enough that if we actually do that, x is simply just going to equal to negative 2z divided by 3. Okay, so now let's actually move on back to y plus z is equal to, or y plus z divided by xyz, equation number 3. So do the same thing. We have xy, substitute that back in. So now y plus z then divided by, so substitute that back in. So I have 8z, then just apply the linearity yet again. Well, let me first write the -1 over 24, then going down below. So do the same thing, y divided by 8z, then equals -1 divided by 24, then z over 8z, that's just 1 over 8, then subtract the 1 over 8. In other words, what I have here is that from the right-hand side, that's just gonna leave us with -1 over 6. So if I just solve this out for y, so from the left-hand side and the right-hand side, if I solve for y by itself, then it means that's just gonna give us -4z and then divided by 3. So let me actually now, with that in mind, so we have something for x, y, and now all we have to do is do something for z's that we can actually form some sort of construction for utilizing these information. So we're actually just almost done basically, in other words. So going back to the equation x times y equals 8, we can actually choose, either way, it doesn't matter. So what I'll do is you can solve for either x or y on its own. So let me actually just go for y, just because that's what I written in my notes. So y is equal to 8 and then divided by the x, but we solve for x, so that means just substitute that back in for -2z, then divided by 3. In other words, that's the same thing written as -12 and then divided by z. Is then we said that y originally was equal to -4z, then divided by 3, then we can actually solve this by itself. So I have 4z squared to just solve for, cross multiplication, simply just equal to 36. And then we get that, so z squared is equal to 9. And then we have two possible answers for z. Z is equal to plus or minus 3. So let me actually just underline this of importance. And then lastly, that we have z is plus or minus 3. So now we can actually get our x and y values just from plugging these in. So to save you all the trouble, we can actually, of course, see that we have two possible answers in this situation. So for one, we have that x is going to equal to -2. This is, of course, plugging in the z is equal to +3. So -2, then for 3, then we get the y. That's actually just going to be -4, and then z being +3. And then the second answer is when you plugged in the -3 for z. So that'll just yield us with +2, 4, and -3. And so there we have it, two possible solutions of triples that actually satisfies the three equations just like that. Quick and simple as, stated. So yeah, that's pretty cool if you ask me.